So we thought we might clarify little things about autophagy and apoptosis and many other things related to how it happens, why it happens, when it's good, when it's bad, when it's ugly. Uh, and I rely on these things heavily on someone with expertise that David has, because he's heavily involved in the circadian rhythms and biophysics exploration. So take me away, David. What's happening when we are experienced autophagy? When do we need it? Do we need it at all? And what's the difference between autophagy, apoptosis, how they working together, how they work against each other, or what's there? Because a lot of people will have heard this by now, but very few understand actually what it entails, what is happening there, and is this always a good thing? Because more often than not, it's almost as a forced opinion that this is the best things that can happen to your body.
Yeah, along those lines, you have the talk of people that, oh, if you fast for long periods of time, you're going to create more autophagy. And that may or may not be true in the essence that let's first delve into what is the difference between autophagy and apoptosis, right? So you might need to let me share if I ask you to share, but I'll share a screenshot of, this will work right here. So the little slide that you're going to be seeing here is this top section is apoptosis, and the bottom section is autophagy. Now, the numbers, the letters, all the abbreviations, you don't really need to concern yourself very much with any of that. What you do want to concern yourself with is this right here. This is a mitochondria, okay, right here in the middle. And this is also a mitochondria in the middle. They are the center point for apoptosis and autophagy. In other words, if you have poorly functioning mitochondria, they're going to signal, hopefully, apoptosis or autophagy. If they don't signal apoptosis or autophagy, that leads to a cancerous state. That leads to a state where you're going to be experiencing all kinds of illness where you are not going through apoptosis or autophagy. So are they generally a good thing? Yes. Now, they are different, right? They're two different words. One, apoptosis is cell suicide, okay? That means the mitochondria is going to send a signal out to the cell for the cell to die, okay? That is like a last resort before becoming cancerous, okay? Now, autophagy is a repair manual for that. So that's going to tell the mitochondria to replicate. So in other words, the mitochondria is going to double and the cell itself is going to double. That's what this represents here. It's the starting of autophagy or phagy or mitophagy. There's lots of words for it. Cell division, okay? Cell division. So in other words, it feels like, hey, there's some things that are broken, not quite working correctly here. So let's divide and make new cells. And when we make that process, we're going to fix any of the bad parts. So think of it like you have a broken down car, but you have this ability to make two cars. And when you do that, you're able to repair the original issues. That's what autophagy is. Now, a lot of people will get tricked into, hey, if you just fast, you're going to create a lot of autophagy. Well, that can happen. You could also create a lot of apoptosis, or you can fast and not create nearly as much of either one of those, because fasting is just not the thing that initiates these. These are initiated by programs at the mitochondria. So if we take that in mind, we have, and this is just another iteration of what I just said, right? If you create apoptosis, that's type 1 cell death. If you create autophagy, okay, so once you've made autophagy, that doesn't guarantee that the cell isn't going to die. There's a type 2 cell death, and then there's the final survival. The thing that's going to dictate one or the other when you create autophagy is the things that I'm going to talk about next, okay? It's the following. This is the electron transport chain in the mitochondria. You don't really need to memorize anything other than knowing this, okay? Electrons from food go through all of these to make water, ATP, and CO2, which you excrete out. But the oxygen that's in this reaction to create water, if you have faulty mitochondria or mitochondrial downregulation or not programmed well mitochondria, you create reactive species, okay? You also create something else that I didn't really find a picture of called nitric oxide species, okay? So this is normal. This is cell damage by being alive. You're supposed to make some nitric oxide reactive or nitrogen reactive species and oxygen reactive species, or ROS, reactive oxygen species, and RNS, reactive nitrogen species. Those two things are what program the mitochondria to either go into apoptosis or autophagy. More nitric oxide species will lead to higher amounts of apoptosis, and less will lead to more autophagy. But if you have issues with creating enough nitric oxide, your body won't distinguish between, do I need to make autophagy happen in certain cells of the body or apoptosis in certain cells of the body, because you don't want apoptosis, for example, in your brain. You do not want apoptosis to happen in your brain because you don't make more brain cells. So if you go killing a bunch of brain cells, you're going through a lot of apoptosis in your brain. That leads to mental diseases like dementia, Alzheimer's, things of that nature. Whereas if you go through apoptosis in your liver, that's actually completely fine because your liver can regenerate. It's one of the most regenerative organs on the, you can literally cut it in half and it's going to be totally fine. So a lot of apoptosis in the liver, totally fine. You want way more autophagy going on in the brain and in the heart and other places, and not as much apoptosis. But how are you going to govern that? Fasting doesn't change one way or the other. Fasting just initiates a low energy state, which then tells the body, hey, this is the appropriate time to regenerate, regroup, or kill. That happens every night. That should happen every night when you go to bed. So if you want proper apoptosis and proper autophagy, there are two things you need to heed. Excellent sleep circadian rhythm. So in other words, getting great sleep. We can do a whole thing on sleep as far as the constituents of what constitutes getting great sleep. But that's number one, because apoptosis and autophagy should be happening every night. But for this video, let's talk about what do you do daily during the day and how that programs apoptosis and autophagy at the cellular level, at the mitochondrial level. The hinge point here is this. Oxygen comes into the cell membranes to create this process and attract electrons all the way to this other end to make this H2O, okay? So the oxygen is going to be coming in and it makes some reactive oxygen species and water. But there's also nitric oxide. It also flows just like oxygen at these levels. So some nitric oxide will come in here and make reactive nitrogen species, and it won't make water. So it slows down the electron transport chain. That is called and again, this is electricity. These are electrons, okay? You're making electricity. This is called a load test in electrical talk. When you induce something that slows down the electrical flow, that's called a load test. So when nitric oxide is introduced into this, it slows the flow of electrons and stress tests the mitochondria. You take the car to the shop and they run it on a dyno and hook it up and view how it's burning fuel. They're stress testing the engine, and then they can tell you whether it's running correctly or not. That's what this is doing. If you don't have nitric oxide coming into the mitochondria, you are not going to effectively stress test the electrical flow at the mitochondrial membrane. If you do, then you're properly stress testing the mitochondria, and then depending on the amount of nitric oxide species and reactive oxygen species that got made and the amount of melatonin that you release that evening, the body goes, hey, these mitochondria at the liver need a lot of apoptosis. These mitochondria at the brain need a lot of autophagy, and we're going to execute these based on the amount of nitric oxide species and reactive oxygen species and the amount of melatonin that got released in the evening by adhering to good sleep hygiene. So now, great, we kind of laid the ground floor of we need nitric oxide. How do we naturally induce that, right? Because everybody on the planet is going to try to sell you something that creates nitric oxide. And the problem is all of those products are not nitric oxide. They are constituents to make nitric oxide. There needs to be manual manipulation to create nitric oxide. And here's just some context. Nitric oxide and AMPK cooperatively regulate this gene right here in musculoskeletal cells. So in other words, there's already research out there showing, hey, nitric oxide has a link with AMPK at the musculoskeletal level for autophagy and apoptosis. Here is exact, so sunlight, UV sunlight without sunscreen, it has to come in here and actually interact at the skin level. We know that it creates vitamin D, right? So it has this pathway to make vitamin D, but the UVB and UVA specifically penetrate deep down enough to actually make nitrate and nitric oxide into the blood, and that affects all these other things. So number one, getting outside in high sunlight environments entrains nitric oxide species. The other thing that does that, or actually here is some actual, this is nitric oxide here. This affects your blood vessels, how they dilate, so it can have a role in cardiovascular disease. It has a role in platelet. So platelets use this because platelets actually have the least amount of mitochondria in all your cells, besides red blood cells. It reduces LDL cholesterol, and it reduces superoxide radicals, right? This goes back to, hey, when there's nitric oxide, there is less likely to be superoxide radicals. It'll just be oxygen radicals and nitric radicals instead of the superoxide radicals. It also reduces smooth muscles, arterial walls, and things of that nature. So nitric oxide is overall a big player in our biology. That's just from the being in the blood, right? So we talked about the sun creating it. Another thing that creates it, nasal breathing floods the lungs with nitric oxide. So now you're entraining mitochondria at the level of the lungs, and the lungs are oxygenating your blood, right? So nasal breathing, a great way to induce nitric oxide. Getting outside in the sun, a great way to induce nitric oxide. And then another thing,
also usually suggest go outside and do just nasal breathing for 20 to 40 minutes. And funnily enough, a lot of issues will get resolved just by doing something without ever spending money anywhere.
right. And now the last thing that's also an environmental factor is cold increases nitric oxide synthesis. So in other words, the ability to create nitric oxide when you nasal breathe, or when you get outside, or when you exercise, gets increased by cold exposure. And cold exposure itself, at the skin level, will create nitric oxide. So the pink skin that you get when you get really cold, that's the same pink skin that you get when you get out in the sun. The skin is pink because it's created. Okay. When you do a lot of nasal breathing, if there was a way to kind of look into the cavity, you would also see the same thing. The blood vessels get more amplified, they get expanded. There would be a lot more red and pink inside the nasal cavity when you do a lot of nasal breathing. So right off the bat, here are three simple things that start to entrain the mitochondria everywhere in your body, the correct signals of whether it needs to perform autophagy or apoptosis. And then the third player is that evening, right? Now, to ensure that that happens is good sleep hygiene. We can do another video on, exactly what that entails, but hopefully this kind of gives a lot of people the ins and the outs of apoptosis, autophagy, and what is the actual central driver, the central programmer for the mitochondria. The mitochondria are the central driver. They're the things that execute autophagy and apoptosis. So programs them, the amount of reactive oxygen species and the amount of reactive nitrogen species.
So long story short, autophagy is something that's predominantly beneficial, but you need to understand that you can actually harm yourself if you haven't laid out proper structure of your daily habits. So be careful of not trying to just starve yourself for the sake of expecting some kind of miraculous recovery from this. If everything else is not in line, you might be actually doing more harms than good. So get your lifestyle habits in check, make sure that you do little simple things that cost nothing, gives you a great amount of benefit. We both know we prefer things like, hey, if you go into a gym or facility where you work out or do something physical, strenuous, or even go to work, can you spend some time outside before you enter the facility? And if you can spend the time outside exposing your skin to sun or cold whilst doing some nasal breathing, will do you more good than harm, because it's not only increasing your physiological ability to stay healthy, but it also gives you some kind of mental clarity, because nasal breathing will bring you down from sympathetic to parasympathetic state as well. Does that sound like a decent summary?
Yes. Yeah, absolutely. And that's the key, right? It's not just about working out. It's about what do you do after, right? Working out is only the stimulus. The recovery for the gains that you're trying to get, whether that's, physique changes or just being healthy in general, that comes from the recovery side of things. And the recovery side of things starts with getting your biology to integrate correctly into the right signals that you're wanting to send. And all of those have to do with being a biological creature on this planet. The key point being you need to be part of the planet somehow at some level.
Awesome, David. Thanks for your time as usual, and I'll see you in our next videos.
Awesome. Thank you.